Hello everyone, and welcome to Jumper Man Tech, where we specialize in HVAC but do everything DIY. And today we have a service call for a 2-pipe fan coil unit. Thank you to everyone tuning into Jumper Man Tech. Today we have a service call for a 2-pipe fan coil unit. Right here we can see that the room temperature is 56 degrees. It is set to 71. And it says the heat is on, but it feels like it's cooling, and it totally is. First things first, when we open up this panel, why do we see this? That is our intake air. There's supposed to be a box around here for our filter. So right off the bat, this unit is unfiltered, and this is not the first one I've seen like this in the building. For another room that we need to work on, it's missing, and so is this one. It's just gone. There's supposed to be a cover here with a box and then a rack for a filter. Can't imagine how dirty this thing is. Oh man. Here's the supply air grill. 53 degrees. Yep. This unit's cooling when it's supposed to be heating. This is a McQuay unit. Daikin bought them over. Let's see, it says this unit dates back to December 2005. This thing is a bit of a dinosaur in the game right now. Let's take off this electrical panel. Hope you're hungry for spaghetti. That's the spaghetti wire right there. Let's take that. All right, we got 2 relays in here. One not being used, this one. Okay. Also, there's no lights on this relay. Usually if it's in heating, one light goes on. If it's in cooling, the other light goes on. Okay, we have an actuator here. It seems like it's open. What the hell is that? Oh, right there. Now it closed. It's like a little, let me take this out for you guys so you guys can see. This is the actuator. To release it, you pull this tab and pop it off. So what I did was I moved this here, and it's supposed to spring back. The actuator didn't fully close at some point. This piece might be bad, or the valve itself is giving it a restriction. Oh yeah, I'm moving the little valve head here, right here. I don't know if you guys can see. Ooh, that's when I close the water. Makes like that popping sound. Makes that popping sound. But that's probably closed now. There's a lot of force going against it, so maybe this spring ain't doing it. Looks like this has changed. They try changing these all the time. And before they call me, they change the actuator. At that point, they just give up. So this is probably actually new. Probably is a bad valve. It's probably not letting it close. Another thing is, it says the heat is on. I don't feel no heat. I don't know why that relay is not lit. This is gonna be, all right, I can see there's 2 thick wires going up, one red, one white. The red and white, that's our heaters, those thick wires. Oh, look at that. We are heating. We're pulling 8.1 amps. So this was mixing heating and cooling, because this valve, this is an actuator that didn't fully close the valve body. It's a 2-way valve. All right, look at this now. It's kind of stuck. That's actually that's stuck open. Hold on a second before I start condemning valves over here. Oh look, now it just moved back. What the heck? This actuator is probably bad. I just want to confirm something. Is it being restricted in the sense where it is getting power but it's not really doing its thing? I don't know. Let's see. Is this getting 120 volts? That's another good question. It sprung back, so it shouldn't be getting any voltage. Let's just double check I'm making a good connection in here. Shouldn't be getting any voltage. Let's do that carefully. Take this off. I want to see the leads touching. That's a very poor connection on there as well. So let's check across. No voltage. No voltage there. And we got amperage here. You can see here we have resistance now on this. That's what closes the valve. I sprung it open. Now it's springing back. And look, now it's stuck, you see? Now it's not springing back. Let's push it back a little. Now it's springing back, you see that? This thing is bad. This actuator is bad. We really get poor heat when this thing is in high speed, so I usually leave it in medium, so less airflow across that coil, especially cold airflow in this room. It mixes with the heater anyways. Put it on medium speed, Chris. Medium speed. Hold up a second. This motor's buzzing and it's slightly moving. Hold on, Chris, stay there. See, I got it going now. All right, put it in low speed. Low speed. That's low speed? Yes, sir. What the heck? All right, something is really off here. Look, it's in low speed and the heat is still on. Geez, turn it off, turn it off. I'm gonna burn out that heater with that fan like that. I know the guys in the building changed these motors. Look at that. That looks brand new. But they probably didn't change the capacitor. I would like to see if that capacitor is bad. Also, I spun it by hand in medium speed and it went. But nothing happened in low speed. I gotta look into this wiring. Oh man, there's always some hack jobs on these units. Looking at the diagram, it says that red is low speed, blue is medium, black is high. These are the motor wires here. I tracked them down. So this white is my neutral, black is high, blue is medium, and red is low. Christian, go over to the thermostat. I know if high speed works. Let's just watch it. We're gonna check between high speed and neutral. Put the system on high speed fan. All right, we got 120. I heard the relay click, so we're in heat. All right, hold up. Christian, put it in. Why do I have 139 volts? Wait. Stay there, Christian. We got the proper 120, right? You got a 118.9, that's 120. Why is there 138 volts? Put this, why is it going to both? Is there anything here? And then 198, what? On low speed? Christian, put it in medium speed.
Medium speed.
Now we got 120. And the motor's humming. And I got 154 on low speed. What? Put the system on low speed, Christian. See, now I got 120 on low speed. What the heck? And nothing's happening. Nothing's happening. All right, turn it off, Chris. That makes absolutely no sense to me right now. Is it the motor? Is that capacitor throwing us off? All right, that should be power for the unit right there. Christian, make sure that the display on the thermostat just went off. Let me know if it's off.
It's off.
It's off? All right, so that was the power switch to it. There's a capacitor there. I want to get in there and take that out. That's a bit tricky. All right, I got the cover off for the capacitor. Let me short it out real quick, just in case. Okay. I don't want to get shocked here. You guys might not be able to see what I'm doing. It's really tight, but what I'm doing is taking off the wires for the capacitor. There's 2 terminals on the capacitor, and I'm gonna check. I'm gonna see what the rating is, but I'm gonna put my meter to read capacitance. I'm gonna read microfarads. Let's see what we got here. It's a silver capacitor, so we know it's a run capacitor. It says 4.7. 4.7. Let's see what the rating is on the capacitor itself. Here's the capacitor. It says 5 UF. So we had 4.7. All I did was check between these two. We got 4.7 microfarads. And when I look at the motor is rated for 4 microfarads. Honestly, this would make the motor run. It really would. It should have a 4 microfarad capacitor, but the 5 would do. The 5 would do. I don't know why it has those strange readings. Okay, so I want to isolate this motor. Red to red, black, and blue. I want to read voltage. Excuse me. I want to read voltage here. What's coming out of that thermostat? This might be a bad motor. The windings in there, something might have messed up. That's why we're getting all those strange voltages. Capacitor is there, so it would start it. It would make the motor run. We need to make sure we were getting 120 each time through there. I want to see it isolated from the motor if we're just getting an actual regular 120 and not all those crazy voltages. That's kind of weird. I think this is a bad motor. I wonder if there was any loose connections, because I'm feeling this. That's pretty loose. These are guys, I'm not professional, so we're changing these motors also. Anyways. Alright. Red's to red. We know that. Blue to blue. We know that. And this one is purple to black. Let me strip these back. Okay, let me strip these back. I'll have Christian work the thermostat. And we're gonna check voltages again. If we got the regular 120, that motor's done. All right, turn the power on. All those fan wires are off. We're gonna put in cooling. We don't want this heat. We don't want that relay to engage and turn on the heater with no fan. You put the system in cooling?
Yes, sir. Hold on.
Lower the temperature below the room if you could. It's pretty cold in here.
There you go. You good?
Okay. Huh, that's so weird. I just saw this thing try to move a little bit. And then it stopped. It's in cooling, right? It says cool on.
Yes, sir.
It's set to cooling, right?
Yes, sir.
All right, this actuator is getting 120 volts, and it didn't actually open. It only tried to. See, it's closed. To the left is open. Look at that. This thing is done. All right, so the actuator is done. I know the auto changeover switches work because when cooling, the valve turns on, and there's no heat. Okay, and I want to check one more thing. Make sure this auto changeover switches work so we could know 100%. Christian, hold up. Put the system to heat. Okay. We lost the voltage there. So that valve closed as it should. And now we have heat. All right, turn the system, put it back to cooling. I'm gonna test these fan wires. What you got, low speed right now? Low speed. 120 volts. Nothing on the others. Okay. Put on medium speed.
Medium speed.
Right there, you saw? We got 120. Nothing on the others. High speed. Next wire. 120 between there. Just 5 volts on the other, so that's nothing. Okay, turn the system off. This thing tried to do something again. All right, this actuator is bad. And this fan motor is bad. That capacitor is oversized by 1 microfarad. You should have the correct capacitor for the correct motor. Also, there's no grill here for filtration. There's no filter rack and there's no filter. This coil must be packed. Oof. This is a mess. At least the auto changeover switches work. Those things are confusing, but electrically it's doing its thing. But we got 2 bad components screwing us up. We're outside of the room right now, closing the supply and return lines for this unit. So here's the deal. I spoke with the engineer and we're gonna change not only the actuator, but the whole actuator assembly. So I have a new actuator, I keep it in the truck with a whole new valve body. That's that right there. I also have a 4 microfarad capacitor for the motor. He wants us to change the whole assembly. When it comes to that, look at that space. This light, how are you gonna change the valve in there. And you got this drain pipe, everything in the way. You're not getting in there. And if you do, it's gonna be a whole disaster. If you follow that pipe, see where the copper is exposed, you cut that open. And I'm gonna install a valve here. I'm gonna leave this actuator on the valve up top, stuck in the open position. You can see, let's see, hold on. Over here it says open. You can force that open and then push this spring down. And now it's forced to open all the time. So now it's acting like basically nothing is there. Then we'll install this on this pipe where I have space to actually do my work. And that's gonna act as the main actuator and control the water. He says, the engineer said he has a new motor in stock. So we're gonna grab that and replace it. And I have the capacitor, if it's the same exact motor, 4 microfarads, 440/370 volts AC, which is what we need up top. Let's get this nightmare started. As far as the whole filter situation, well, you know, it is what it is. The part is gone. They're gonna have to order something. This unit goes back to 2005. If they find something, it'll be a miracle. If not, I gotta get creative and like build some sort of filter rack on here. Unreal. This is a tight space to work with too. I can't even open my hand all the way. That's about the space of my hand. Getting in there to do all that soldering and all that stuff, forget about it. So I got a garbage bag in here set up so we can drain. Got my pipe cutter and we're gonna cut the pipe. We got the supply and return closed in the hallway. Those valves were all installed a couple of years ago, so I trust them a bit more than other things in this building. Oh, this hanger ain't doing nothing. That's beautiful. Alright guys, let's cut this slowly and let it drain out. Hopefully this holds. And if those valves don't hold, I know of another main valve. I'm gonna have to shut the whole floor down. But like this, the rooms are isolated. Alright, got it just about cut. I'm gonna push down a little and let it drain out. Put some tie wraps here and some tie wraps here just to support this little section when I cut it out. Alright, that looks good. That looks good. Oh, thank the Lord. What we're gonna do is cut that down the middle and put it on each side. I'm gonna solder this valve on and I'm gonna press on those fittings up there. So I'm gonna solder outside of the space so it's comfortable. No torches or anything like that in the ceiling. There's also sprinkler pipes and all that stuff in the way. Definitely gonna go press there. I got 2 3/4 no slip couplings and we're gonna be good to go. That tool is a lifesaver regardless of what anyone says. All right, let's cut this pipe. All right, we're just sanding down the pipes, outside of the pipes and inside of the fittings. Christian is sanding down the pipes there. And this is what I meant by inside of the fittings. The only fitting we're gonna be really sanding down is this valve. Brass valve, copper piping, 3/4 size. Here's a deburring tool. We're also gonna deburr the inside and outside of our fittings. Let's start by doing our hot work. And we're gonna put flux on the inside of our fittings. And the outside of our pipes. I have this set up here and we're gonna wipe away the excess flux. You really only want this inside of the pipe. Also, another thing is we're gonna want this valve open so it can breathe while we're soldering. That's closed right there. You spin this handle and that's open. so air can pass through. Hopefully we don't build too much heat in there. And we're ready to solder this thing. I'm using wet rag, heat blocking putty over the valve, and this is gonna protect it. Also, there's paper on this valve. If that doesn't burn, then this product is definitely doing its thing. I'm gonna absorb heat that I'm gonna apply so we don't damage this valve. You wanna heat the valve itself so the heat gets pushed in towards there and the solder gets sucked inside via the flux. It should be enough for me to heat it. Well, let's see what happens. And the next one. Beautiful. That is a clean soldering job. But pay attention to this. It didn't even melt. It didn't even melt the sticker on here. That's amazing. That is amazing. That heat blocking putty is definitely awesome. I feel a lot more confident with that. You don't use as much heat for solder, but you do when brazing, especially like TXVs and stuff like that. You definitely want to protect it. There's a lot more heat. Anyways, this thing is ready to go up. I have 2 3/4 couplings, but specifically Viega couplings. They are a lot better, and even more specific to that, no stop couplings. So usually when you put in a coupling, it stops over here and slide it across the pipe. And when you don't have any space to work with, this thing comes in clutch. So let's see, what I'm gonna do is find the midpoint here, and right there should be good. So I'm gonna mark one side here. Okay, and I'm gonna do the same for this one. There's an arrow on this valve. This needs to be installed the right way. We know that the line we cut is the water supply. I can show you guys a picture, but that is gonna be our water supply. So we want that feeding the unit. So I'm gonna put the arrow towards the unit. I'm gonna go put this in place here and slide it over. A bit, and then here, let's line that up and slide this coupling over. We're gonna want to position our coupling in the right spot where we marked it. Okay, right there. Make sure everything is in. Now let's press it. Next, that looks good. Okay. All right, my marks are there. Oops, I started it by accident again. What I do is press it. Let it finish up. I got a green lock there. Let's just make sure this right there is all the way in. Okay. Okay, and let's hit it. And there you have it. This thing's amazing. All right, guys. That right there is a beautiful thing. Let's put the actuator, let's put the actuator on there. Force it into open position so we can check to see if there's any leaks on both sides. We're gonna open up the water. Let's just get this on there. There we go, and we're forced open. Supply and return water lines are open. You can hear it if you listen closely. We got no leaks. That's a beautiful thing. As far as here, I'm gonna take off these wires. There's a little locking nut that's loose. And that's it. I don't think I'm gonna reach to the new valve. What I'm gonna do is, I have this propped open. I'm gonna put that up here and just leave it propped open. And now we're gonna use that valve. Right there. That's propped open. As far as this, if it reaches, it'll be a miracle, but I don't think so. Yeah, it doesn't reach. This VX doesn't reach here now. And a lot of people will just make a shady connection just like that with wire nuts, but I don't want to do that. I'm gonna redo this. I already figured it wouldn't reach because they did everything so short here. I have BX and wire. I'm gonna run it and make a nice hard connection from the valve to the unit. Power is gonna come in, got a connector, and I made my 2 connections here. That right there looks so much better, and it's a lot safer, and it also looks beautiful. All right, pop that back on there. Now we can run this. You know what, let's go above. Up top. Let's just run that nicely. And we're gonna make the connection in here now. All right, it looks really nice and neat. I put fiberglass insulation in there, it looks nice and clean. I just gotta do a little something here. Made all our connections inside. Right now, let's focus on this motor. This capacitor is done. Get that out the way so it doesn't just like shake everywhere, smack me in the face. Okay, whoa. So we're here, we got a couple screws on the side. It should be two here and 2 on that side. A couple of 5/16 screws. Oh, you know what, before I do that, I already have these wires cut. Let's pull the wires through. Okay, I'm gonna drop the whole plate. Okay. There is a little hook on them at first, so it kind of keeps it in place. You hold that. Alright, this whole thing should come down. And this is loose. Okay. It's good they took out that whole guard. Made this a little easier. Okay. What a mess. mess. Surprisingly, right, this is the electrical heater. Surprisingly, that coil ain't too bad. Not too bad, considering there's no filter here. Let's open up this housing. Keep it the same way like that. I got these resilient mount screws right here. Loosen that up a bit. Loosen that up a bit. These little things should come off. Now let's open it up a little more. Almost to the end. So these little clips. Okay. And this whole thing comes apart. And there you have it. We're gonna have to redo and install this blade. But let's go and see, make sure they have the same motor. Take off those screws. Oh, we gotta loosen this up because I can't get to the screw. Let's loosen that up. Can we get that off? Yeah, I gotta take the whole thing off. Yeah, that's one piece. I just gotta take the top off. I should be able to now twist this. Get that out. Oh, that's a nice little setup right there. Let's take this bracket too. This little capacitor bracket. I don't know if that one comes with it. Here's the old motor. And I was able to track down the same exact one which they had in stock in the building. Here's the new motor. It does come with a little mounting bracket for the capacitor. This one is super easy to take off. There's just a little clip. I'm just gonna squeeze on it a bit and pull it out. We're gonna wanna put this on the same exact way. There we go. This is a round shaft, but there's a flat part. Just gonna wanna match that up the same way. Take that out. Get that about in place. And you're just gonna squeeze that little clip back in there. And that's pretty much what holds it in place. What I'm gonna do is mount this motor and then make the proper adjustment for the blade. So I'm gonna get that in place. Right there. And put our little clips back on. There we go. And tighten it up. Okay. And the other one. Let's put it where if they don't want to take the whole blower down, they can get to the screws from the bottom. Let's have it in the same orientation. Awesome. So, see right there? It's scratching. You want this to be a little further out this way. Pretty much even between here. And that is how you know you're in a good spot. We'll move it just a little bit more in. Let's put the other cover on and confirm that. Let's just fit this plate in. That goes there. There we go. None of these screws, see, they just keep spinning. You don't want this to get loose. I'm probably gonna drill in some new screws. Keep that tight. There we go. There we go. That ain't going nowhere. Even on this side, all this stuff is like loose. There we go. There we go. I'm gonna need another attachment for this, but we want everything nice and tight. Everything is nice and tight now. You want this blade in between here so it doesn't scratch. Spin it by hand so you see everything is good. Now we can lock it down with that little clip. Also, I'm gonna brush this down, clean it up a little bit before we put it back. We're gonna put this little clip in. Sometimes this thing is tricky. Yep, sometimes it's tricky. Basically wanna expand it a little bit. Let's try to get it on there. Alright, that clip is fully in. Everything is nice and smooth. Here we have a brand new 4 microfarad capacitor, rated with as the motor requires. Open that up, get it in, close it up. Before we start going crazy or get played up there, it's kind of tight. Let's check. 4 microfarads on the money. Beautiful. Okay, we cleaned all that up. That looks a lot better. Brushed it down. I put this cable back on so it's nice and clean. Capacitor is mounted on there and clean. Put my little ground wire on there. New screws, everything is nice and tight. We're ready to go up. Okay, let's squeeze this thing in here. This light might be in the way. What I'm gonna do is get it in there. Let's try not to disconnect any of this wiring. And then there's like a little hook. Get it in the ceiling. There we go. Camera cut out because I have to charge it, but I pretty much placed it on the hook and put the 2 screws on this side, 2 on the other. Everything looks good. Made my connections here. And I finished insulating this piece here. I put some cork tape underneath with some white tape to match. Looks good. All right, the power's back on. All right, Christian, let's put it on low speed. Good. Let's put it on medium speed. Looks like it's slowed down. Put it on low. Low speed seems higher. Something might be crossed up. Oh, there we go. Now that's low speed. That's weird how it sends those signals there. Now that's low speed. Put it in medium. Gotta give this thing like a minute. Let's see what happens. Start up a bit. High speed. There we go. We got all our 3 speeds now. And it's nice and quiet. Beautiful. All right, Chris, put it in cooling. Just right now, it's tight. Oh, you see the valve slowly opening? Beautiful. See, this is loose. Right here. Turn it on, off. See, it's springing back, no more noise. I don't hear water squeezing through. That's good. And let's put it in heat and medium speed. Got no heat, no amps on there. Give me a break. All right, check that relay. Actuator is operating, opens and closes. Heat, excuse me, the fan, we got all 3 speeds. We got the new motor in there, everything new connections. Got the correct capacitor. I don't have amps. It says the thermostat is on heat. It said heat on. Give me a break. Let's check that coil voltage. Should have 120 volts here. And we do. Electrically, it's sending voltage there. Jesus. Cross here. Nothing. Got 120 volts going to the heater. Geez, something's up with the heater now. No amps on the heater. Give me a break. Alright, something get loose or what? I want to see something. Look at that. This wire got loose. Oh, it's a very loose connection on there. Loose connections. Jeez. All right, let's crimp that down a little bit and get it on there. It's a lesson for us all. Always double check all your connections when messing around. Doing stuff like this. If pulling on this little wire, that's it. Well, that's good news. At least the heater's still good because it worked earlier. Everything is now nice and tight. Unreal. Okay. Oh man, another wire just got loose. What is going on today? Wire nut just came off. Got bad connections on these units. Anyways, that's back up there. At least you guys get to see how that's done. Kind of hang it on a hook. And we're just gonna put the 4 screws back. Alright, as far as this wire just got loose and the wire nut fell off. That actually might have been capped off alone because everything else has wire nuts. Let me look through this real quick. Oh man. So I just traced this out. That was just capped off because how did the wire nut fall out and everything, all the other wires are connected. One of the auto changeover switches, this one capped off. Then the next wire to it capped off. So it's not actually being used. Here's the cooling wire coming from the thermostat, yellow. It energizes our actuator. That's it. It's not sensing any pipe temperature. And then here's the brown wire. Here's the brown wire, which is our heat wire at our thermostat. It goes to this red, and this red goes directly to the coil of that relay for the electrical heater. So these pipe sensors are not even in the circuit. So good thing I actually I guess this came loose. So now I see another problem. They need 2 pipe sensors here, and they need wire through the system. If the water's cold and they want cooling, the valve will open. If they want heat and the pipe is hot, then the valve will open. But in this situation, if the water is cold and they set it to heat, it's going to keep that valve closed because the water temperature is cold. It's going to know that, and it's going to redirect the energy to the coil of that relay, so it turns on the electrical heater. They use the electrical heater when it's cooling season, so it is what it is. Chris, let's put the system on heat. Let's put the system on heat. We should get amps. Come on. Okay. There we go. Now we got amps. Now we got heat. But electric heat. And these electrical heaters really don't do the job in this room. Either they're just so old, 19 years old, and they just don't give out the same energy, or they're just completely undersized. Got that cover on. I just heard the relay click for heat. Got it in low speed. I didn't do any tests with voltages or anything like that, but we got the speeds now. We saw clearly we didn't have it before, and some super strange voltages. If there was still that problem, this thing would have been giving off the same issues. Anyways, we just got another service call for another room. We gotta get that going. We've been here like all day already. One thing I'm noticing here, it says supply 2 electric heaters, 1 kilowatt. But there's only 1 electrical heater in here. Maybe that's why they have very poor electric heat in these rooms. Every time they turn the chiller on and they have these cold days where we need to put the electric heat on, there's always complaints. Always. Probably running at 50%, considering it's only 1 heater in here at 1 kilowatt. Oh boy. But anyways, we're gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.